Question 14b. The shaded region shown in the diagram is bounded by the curve y equals x to the power of 4 plus 1, the y-axis, and the line y equals 10. Find the volume of the solid of revolution formed when the shaded region is rotated about the y-axis. The following are the marking guidelines for question 14b. For 1 mark, we have attempts to use an integral of the form pi times the integral of x² dy, or equivalent merit. For 2 marks, we have obtains correct integral for volume in terms of y only, or equivalent merit. And for 3 marks, we have provides correct solution. Since the solid of revolution is formed by rotating the curve about the y-axis, the formula for the volume of the solid of revolution formed is v equals pi times the integral of x² dy. Hence, the first step is to make x² the subject of y equals x to the power of 4 plus 1. Rearranging this equation, we have x to the power of 4 is equal to y minus 1. And then taking the square root of both sides, we have x² is equal to the square root of y minus 1. And the positive square root will suffice in this case. Now v is equal to pi times the integral from y equals 1 to y equals 10 of x² dy, where v represents the volume of the solid of revolution formed. And x² is equal to the square root of y minus 1. And expressing this surd in index form, we have volume v is equal to pi times the integral from y equals 1 to y equals 10 of y minus 1 to the power of half dy. Performing the integration, we have v is equal to pi times 2 over 3 times y minus 1 to the power of 3 over 2 from y equals 1 to y equals 10. Applying the limits of integration, we have v equals 2 pi over 3 times 9 to the power of 3 over 2 minus 0. And 9 to the power of 3 over 2 is equal to 27, so v is equal to 2 pi over 3 times 27. Therefore, the volume is equal to 18 pi cubic units. The following is the feedback from the Marking Centre for question 14b. Skills addressed. Stating that v equals pi times the integral from y equals 1 to y equals 10 of y minus 1 to the power of half dy, and integrating and substituting limits correctly and presenting all intermediary steps. Areas for students to improve include understanding that rotating a region about the y-axis requires the formula v equals pi times the integral from y equals a to y equals b of x² dy, where a and b are y values. Using algebraic skills to find an expression for x² in terms of y. Integrating using the reverse chain rule, and choosing and applying the correct limits.